When you spend any amount of time with a data center, it's been my experience that you encounter a lot of problems. We need to protect all of our information. If our data is not protected, it really affects the viability of the entire organization.
Behind me here is the University of Utah Hospital. All of the medical records are stored down at the University of Utah Data Center. So we can't have it go down. You have to have the generators come up, be paralleled, and be running right in line when the university power is lost.
There were a couple of things that we were trying to solve with this facility. One of them was just basic expansion. We were out of power on campus. There was nowhere we could build on campus. And the availability design was completely inadequate for the application.
They were looking at traditional solutions for emergency power, but they had sound requirements and footprint requirements that wouldn't allow them to use traditional generators.
The university had a very tight budget constraint, and we were trying to balance everything across the mechanical, electrical, and architectural systems. Generac approached the team and said, hey, we would like to take a look at this. We think we have a solution. And that's when we started talking about the 1 megawatt modules and the paralleling bus systems.
We can actually provide a better engineered solution for the data centers than what the larger 2 megawatt can.
The benefit would be to have multiple generators paralleled, so if anything went wrong with any one of them in that time frame, we would have a backup to that. That project uses Gemini generators, 1 megawatt per box, but we're scalable up to 9 megawatts. At the drop of a hat, we produce power. We looked at the control system and integrated it into the generator. We can take generators, put them next to each other, and they synchronize, they share. By using our controls, we can provide those generators at a fair price, give you more scalability, more reliability, more redundancy, and a better footprint.
Most data centers average a PUE, or a power usage efficiency, of 2. This is below 1.3, around the 1.2 range. That means that you're spending nearly half as much electricity to run the same equipment.
The university purchased 11 minutes of UPS battery. They probably only need about 30 seconds of that because those generators, they started up within 6 seconds. Fundamentally pleasing.
Quite honestly, they were very, very skeptical about them being up, paralleling and syncing in 6-7 seconds, whatever it was that we ended up getting that on there with. At first, I didn't believe it. But then once it happened, then I think they were calling saying, oh my gosh, you need to come up here and take a look at this. I mean, it happened over and over. I mean, it's a sustainable result, which is how it should be.
Yeah. They allowed the data center to grow at a pace that's comfortable for them. So the fact that the 1 megawatt generator was a smaller footprint, it's going to make it that much easier for them to add the next module and just grow as they need to grow.
From a sheer installation standpoint, it's a lot less expensive, cheaper to buy, faster and easier to install. I would install a Generac generator on every project if I could.
The project came together smoothly, on time, and under budget. The comment made from the University of Utah is that that was the best decision they made on the project.
A true partner, I appreciate it. Cancer research, genetic research, the nonstop operation of those generators is critical to these very important missions that we believe are making the world a better place. Generac has been a great partner in bringing that about.